Okie doke. So it's 6 o'clock. Let's get started. I hope everybody is well. I think it was the first day back at school for a lot of us today. You guys probably don't have much school left, probably about another week or so, and then you'll be on your final study leave. But of course, Watobe is going to continue going. So we really hope that you guys will continue to join us right up until when you write those final exams to get the best results possible. Okay, so today we're going to talk about functions. And I have selected some questions for us to work through together, sort of typical exam type questions. All right, so the very first one, let's jump straight in, is S of x. So given the graph S of x equals a over x plus p plus q, having the horizontal asymptote intersecting the y-axis at 2, and the vertical asymptote intersecting the x-axis at -3, the point 0 and 0 lies on S. So we know that it goes through the origin. So this particular hyperbola has been shifted to the left and up. All right, so to the left by 3 units and up by 2 units. Let's see what the questions are. Okay, so what I'm going to do is grab them and just shove them over here. And then we can always just pull them down if we need to. Let's just move, whoopsie, let's move that over a little bit. Hang on a second. There we go. Okay, all right, so let's get cracking. So the first thing that they want us to do is write down the domain of S, and this is for 1 mark. The domain of S. So what is a domain? What are they asking us for? What does the word domain mean, Matrix? There we go. All right, Boitshepo, so they want us to write down the values of x. Okay, so the values of x, so our domain. All right, so what do you think it should be in this case? Remembering, of course, that it is a hyperbola. What would our domain be? What would you write? You guys are so quiet tonight. Okay, so Boitshepo, I think what you're trying to say there is that, and it's very important that we write both things here, all right? So we have to state that x is an element of the real numbers, okay? Because this is, it's not a continuous function, but x is an element of the real numbers, right? But it's not continuous because x is not allowed to be equal to -3. Okay, so to get 1 mark, you have to have both of those things. Okay, so x is an element of the real numbers. X may not be equal to -3. Okay, the next thing that they want us to do is write down the values of P and Q. So the values of P and Q next. What would P be equal to? Okay, remember up here, they've got x plus p. So what would p be equal to? Okay. So Tisha, you just forgot to change the sign of the p, okay? So p would be equal to -3. No, sorry, I'm not changing the sign. P would have to be equal to 3. Sorry, opposite sign. Okay, so P would be equal to 3 and Q would be equal to 2. Sorry, my apologies, you were correct. Okay, so if it's been moved 3 units to the left-hand side, it has to be X plus 3 inside the brackets. Yes, Boitshepo?
Ma'am, like I always get confused when it comes to like the P one. Like the Q one, I'm fine. It's just the fact that when it comes to if the number's like -3, they will always change it like P is equal to 3. And then sometimes when it's positive, it says P is equal to -3. So then sometimes I get confused about must it be a positive or must it be a negative?
100%. I can understand why that is confusing for you, because the other thing that they can do for you, Boitshepo, is that they can give you the equation in one of 2 forms. So either they can give it to you as X plus P, which is the correct, or the most correct way, or they can give it to you like this, where it's S of X equals A over X minus P. I think we've all seen that before as well. All right, so the first one is actually the correct standard form. That is the one that we are supposed to be using. What you need to remember is that whatever you see here, your P needs to be the opposite of that. Okay, so in other words, if it's been shifted to the right-hand side, your P is going to be a negative value. If it's been shifted to the left-hand side, your P is going to be a positive value. So just think about it like that.
Thank you, ma'am.
Okay, no problem. All right, so just always change the sign of P. Whatever you see here, you write the opposite of that, and then you'll never get it wrong. Okay. All right, 4.3. So hence determine the equation in the form S of X equals A over X plus P plus Q. All right, so now let's just get rid of all of this. We can go ahead and sub in. So subbing in gives us S of X equals A over X plus 3 plus 2. Right? So if they want us to determine the equation of S of X, what are they really asking us to solve for in this question?
A.
Exactly, Kanisile. Okay, they want A from us, quite right. So in order to get A, we need to know a point that lies on the line. We have to have an X, well, that's a Y, and an X to be able to sub in. So what point do we know the hyperbola goes through?
The origin.
It goes through the origin, quite right, into Maleng. So that means that we can sub in 0 equals A over 0 plus 3 plus 2. So this gives us 0 equals A over 3 plus 2. What do we think we should do next?
Take 2 to the other side.
Take 2 to the other side. I agree with you. That's what I would do. It becomes -2 equals A over 3. And what would you do now? Next step is to cross multiply. Okay, quite right, Kulani, I agree. All right, so we're going to cross multiply, and A is going to be equal to -6. There we go. All right, so because they asked us for the equation, let's just make sure that we write it in the way that they want. So that would be S of X equals -6 over X plus 3 plus 2. Okay, there we go. There is our equation. Okay, and it makes sense because we can see that one arm of the hyperbola is in the second quadrant, the other arm is in the fourth quadrant, so we know that A needed to be a negative number. Okay, makes sense that it is. Now they say to us, a new graph is defined by the equation b of x equals s of x plus 2. They've asked us to determine the equation of the axis of symmetry of b having a positive gradient. So what do they want from us here? What do they want from us? Okay, so right, so the first thing that we have to do is we have to determine the new equation, right? Then they want, there we go, boy Chepo, it needs to be y equals mx plus c, okay? Quite right. But your axis of symmetry that has a positive gradient, what is that gradient always equal to? Does the gradient change if it's an axis of symmetry? Okay, no, you're right. Can you see, like, yes, Tisha. Okay, it doesn't change. So if they are talking about our axes of symmetry of hyperbole, we can learn one of two things. Either we learn y equals x plus k. This is how I always teach it at school. Or we learn y equals negative x plus k. And we never, ever, ever have to worry about calculating the gradient because it's always either one, okay, where it has a positive gradient, okay, or m greater than 0. And here where m is negative, the gradient is always -1. The only thing you need to do is work out the value of the y-intercept, okay, which in this case, I've referred to as k. If you want to call it C or B or any letter under the sun, it really doesn't matter. The other thing that you need to remember about your axis of symmetry, okay, is that it will always go through the point of intersection of your asymptotes. So in other words, this point over here, let me just highlight it for you here, it will always go through there. So the equation of the axis of symmetry that has a positive gradient is going to look like this. Let me just hang on a second. What I want is that. Okay, it's going to do this. That's what it's going to look like. Okay, so it's going to go through the point of intersection of the asymptotes, and it's got a positive gradient. So that means that we know that it passes through the point -3 and +2. So that gives us our x and our y. So we would just sub in and we would say 2 is equal to 1, it doesn't matter whether you write the 1 or not, times -3 plus k. Make k the subject of the formula by adding 3 to both sides, and k has got to be equal to 5. So this has got to be the line y equals x plus 5. Okay, you have to study that. All right, does that make sense to everybody? Oh, but what did I not do? Hang on a second. Sorry, that would be for the equation of the axis of symmetry as it is at the moment, but that's not what the question said, sorry. So here the question said if b of x equals s of x plus 2, then determine the equation of the axis of symmetry, all right? So this would be the equation of the axis of symmetry of the graph as it is now. So this is of s of x, Okay, this is for S of x, but B of x is equal to S of x plus 2. So in other words, what we've got is minus 6 over x plus 3 plus 2 plus another 2 on the end. Okay, so B of x is the function minus 6 over x plus 3 plus 4. So now we know that the coordinates at the point of intersection of the two asymptotes, the coordinates, I'll just write that down for you, the coordinates at the point of intersection of the asymptotes, okay, are going to be, in this case, minus 3 and 4. Does that make sense to everybody? Okay, so Tisha, you say it's not making sense. Where did I lose you? Where did I lose you, Tisha? That's fine. Absolutely, Tisha. You that's what you feel is better for you. That's no problem. I personally think this is the easiest way to do it. I know there are other formulae that you can learn, but in my opinion, this is what I think is the most straightforward. Okay, and you will get the same answer, provided you use the other method correctly, you will get the same answer. Okay, so now we know that it has to be y equals x plus k. So we can sub in the 4, we can sub in the negative 3, and that means that k would be equal to 7. Okay. So thus it is the line y equals x plus 7 is the equation of the axis of symmetry with the positive gradient. Okay, are we all good with that? How are we feeling? Let's just check in with you guys. No, Kulani, k was equal to 5. That was for the original function, for s of x. But remember here, the question asked us, a new graph is defined by the equation b of x equals s of x plus 2. Okay, so they wanted us to shift it up 2 units and then find the axis of symmetry with a positive gradient. Mango fruit. So the gradient is always 1. Okay, either 1 or negative 1. I was just doing this as an example. Okay, using what we've got. This was just an example for you guys. Okay, and then here, this is where I was actually answering the question. So this bit here is where I actually answered the question. Does that make sense to everyone? Okay. All right. Please do ask if there's anything that I say at any point that doesn't make sense. Please do ask questions. Okay, let's move on and let's have a look at the next one. I just need to move it down a little bit. How much does the last question count? I think it was out of 2, which is kind of ridiculous because that's definitely a lot more than just 2 marks. But yeah, that was it. It was only out of 2. I think that's wrong because, you know, you would at least need, in my opinion, it's just my opinion, so you would need a mark for that. You'd need a mark for subbing that in, and yeah, I would say it should be out of 3. I think that's a bit mean to make it out of 2, but anyway, there we go. Okay, we're all good to move on. Let's have a look at the next question. All right, so here, let's move this over to the side. Let's grab that and put that right there. Okay, so question 5. So it says to us, in the diagram below, the graphs of f of x equals minus x squared plus 2x plus 8 and g are shown. Graph F intersects the x-axis at B, which has the coordinates minus 2 and 0, and C intersects the the y-axis at A and has turning point D. Graph G is a straight line passing through A and C. So the first thing that they want us to do is they want us to write down the coordinates of A. So that's just for 1 mark. What are the coordinates at A, Matrix? Good, well done. Okay, so 0 and 8, the coordinates at A. Lovely. Good job, everybody. 5.2 now. Calculate the coordinates of D. How are we going to do that? Turning point of F. A number of different ways. I think we should talk about at least 2 of them. What would you guys do? You could complete the square, but you know what I would do, Tisha? I would stay away from completing the square. Like, I would honestly only complete the square when I absolutely have to. And there are some questions where, you know, they expect you to complete the square to find a maximum or a minimum, because there is no other way of being able to do it given the nature of the question. But I would stay away from completing the square. But yes, you're right. Completing the square would be one way of doing it. But there are 2 other ways that are much easier. Okay, so Itumeleng, yes, use the minus b over 2a method. Absolutely. I think that's what I would do in this case. It would be the quickest one. That's it. Okay, and then we can talk about how else we could answer this question as well. So if we use the x equals negative b over 2a method, then we would end up with negative b being negative 2 over 2 times negative 1. All right, so that would give us an x coordinate of 1 at the turning point. So then to go and calculate the y coordinate at the turning point, we would now calculate f of 1. So subbing 1 in, and we must show these steps. Very important that we write this down, because we're not going to get full marks for working out answers only. Once you've subbed in, then you can work it out. Okay, so 2 minus 1 would be 1, plus 8 would give us 9. So therefore the coordinates at D would be 1 and 9. And that looks right because it's a point in the first quadrant. How else can we answer this question, Matrix? So completing the square is one way, but we want to try and stay away from that because it's nasty. X equals negative b over 2a. Awesome, nice and quick. There are 2 other ways that we can answer this question. The second way, not so easy with this particular. How else could we answer this? Anyone got any ideas? So matrix D is a turning point, isn't it? So D is the turning point. What's the gradient at the turning point? Exactly. All right. So the gradient at the turning point is going to be equal to 0. So at the TP, the gradient is 0. So that means that your first derivative is equal to 0. So we can derive, this is going to give us minus 2x. Let's just go back and look at the formula. Minus 2x plus 2. At the turning point, the gradient is 0. And now we can take our 2x over to the other side. And x would be equal to 1. Okay, so that's an alternative way of being able to work out the x coordinate at the turning point. You would still then have to go f of 1 equals minus 1 squared plus 2 times 1 plus 8 to get your 9. Okay. Now, the last way that you can do this, just very quickly before we move on, if you had the coordinates at C, you could also use midpoint formula. Have you seen that before? So what you do is you add your two x-intercepts together, divide by 2, and that equals the x coordinate at the turning point. So you can also do it by midpoint formulas. There's actually 4 ways that you can find that x coordinate at the turning point, which I think is quite interesting. All right, have you guys seen that method before? I'm sure I've shown you that. Okay, so first principles is a completely different question, Mr. Bavuma. Okay, they're asking you to derive using the original old method for calculating a first derivative. So you're always going to be given a first principles question in all paper ones under caps. And then they want you to use, so in other words, they want you to use that formula. I'll rub it off, but they want you to use it. So f prime x equals your limit as h tends to 0 of f of x plus h minus f of x over h. That's first principles. Okay, so what you would find, you'd still get the same answer, but this is the long way. Okay, so what I did when I derived now is I used the power rule. Okay, this would be the long way of doing it. Right, so you'll see that question always comes up. It's always your first question in calculus. Okay. Okay, all right, so that's something that I must think about doing definitely when we do calculus. No problem. Cool, so question 5.3 says, hence or otherwise, write down the coordinates of C. So this is exactly it, Tisha. Or was it Tisha, or was it, hang on, let me just go back here. Yes, Tisha, you said yes, that you had seen that other method where we use midpoint formula. All right, so write down the coordinates of C. That means that we don't have to do any calculating here. All right, we should be able to just work it out and write down what the answer is. Okay, so we know that at D, the coordinates are 1 and 9. Remember, D, this is an axis of symmetry. It cuts the parabola in half. Okay, so how are we going to work out what the coordinates at C are? How are we going to work out the coordinates at C? We don't have to sub into a formula, Tyler, because they've just said to us, write down the coordinates of C. So it's literally a case of just writing down the answer. There we go. Ashwinetse, I hope I said your name correctly. Itumeleng, calculate the distance from the axis. Yeah, absolutely. All right. So if you guys have a look at what Osh said, sorry, obviously difficult for me to pronounce that. I beg your pardon. Over here to here, we've moved 3 to the right, haven't we? Okay, so to go from there to there. So because a parabola is symmetrical about its axis of symmetry, from here to there, we're going to add another 3. All right, so that's why we would be adding 3 over there. Cool beans. So the coordinates at C would end up being 4 and 0. 3 and 0, 4 and 0. Kulani? 4 and 0? Okay. No, it's just I make mistakes too, so always good to check. Okay, determine the equation of G in the form y equals mx plus c. So how are we going to do that? What do you guys think? How are we going to work out the equation of G? What do they want from us? Okay, into what formula can you see there? Yeah, so you need gradient. So you need the gradient of the line. Remember, guys, the very first question that we answered, they asked us to calculate the coordinates at A, didn't they? So we know here at A, the coordinates were 0 and 8. We've just worked out that the coordinates at C have got to be 4 and 0. So there I'm dropping some hints. That's it, Tyler. There we go, quite right. So what's the first thing we're going to do? We're going to work out. Yeah, we're going to calculate the gradient between A and C. So we need the gradient of line AC, the change in Y over the change in X. So Y2 minus Y1 over X2 minus X1. So that gives us 0 minus 8 over 4 minus 0. So this gives us a gradient of -2. Now we're going to sub that in to y equals mx plus c. So y equals -2x plus c. And now we need to sub in a point. So either we can use A or we can use C. It does not matter. So let's say we decide we're going to sub in. So here we can sub in A or point C to calculate the y-intercept. So let's just go with the first one. So we're going to make y equal to 8, x equal to 0, and that means that c is going to be equal to 8. In fact, that was silly of me to do that because we know what the y-intercept is, right? So we could actually just go ahead and go and write it in. We didn't have to calculate it. But if we had like other points, it wasn't the y-intercept, then we could do that. So that was a bit of a waste of time there. Sorry, I shouldn't have done that. Let's just out and that. Okay, so we can actually just go straight here to saying, therefore, y is equal to -2x plus 8. As an alternative here, the other thing that you could do is this. You can sub in your y-intercept first. So in other words, sub into y equals mx plus c, sub in your y-intercept. So you know that c is equal to 8. Then you can sub in your other point. So the 4 and the 0, and you can actually solve for m. So if you say 0 is equal to m times 4 plus 8, then you would have 4m equals -8. So m would be equal to -2. That's the other way you could do it if you wanted. So thus y equals -2x plus 8. All right, just as an alternative there. How's everybody doing? Are we all good? Yes, all fine. Good. Okay, cool beans. Let's move on to the next question. So in 5.5, they say to us, cool Itomaling, thanks for Chepo. A tangent to f has the equation y equals -2x plus k. Calculate the value of k. And this is now out of 4 marks. So a tangent to f has the equation y equals -2x plus k. Calculate the value of k. So in other words, they want us to calculate the value of the y-intercept of this tangent. So in other words, where does the tangent cut the y-axis? How are we going to attempt this question? What would we do here? What do you guys think? What are we going to do here? So the clue is in the word tangent. When we say a line is a tangent, what does that mean? If we say a line is a tangent to a function, what does that mean for us? Not necessarily, Kanyusile. If the line is a horizontal line, then it can be a tangent to the function at the turning point. But this line is not horizontal, it's diagonal, okay, because it has a gradient of -2. So in fact, it looks very similar to this line over here. It has the same gradient, right? So if I draw it onto my function over here, it would look something like that. Sorry, I've got Christmas beetles flying around here. Okay, so it would look like this. So yeah, so only if it's horizontal. If the line is horizontal, then it can be a tangent to the function at the turning point. But this is not a horizontal line. This is a diagonal line. All right, so that means that it can move. Oh, what did I do? Sorry, I'm just busy pressing buttons here. So that means that it can move. All right, so I don't know if I can get it to do, whoop, goodness, what am I doing here? Okay. There we go. All right, that's what I wanted. Okay, so can you see here, can you see when I move it to that point over there, it's not going to be at the turning point. It's going to be somewhere here on the side. Okay, it's only if it was horizontal. Okay, if it was horizontal, let's just make it horizontal, then it can be at the turning point. But this is not a horizontal line. This line has a gradient of -2. So therefore, it cannot be a tangent to the function at the turning point. Does that make sense? No, it's only touching it once, Tisha, because it's a tangent. Okay, so maybe mine is a little bit thick and it looks like it's touching it twice. Let me make it a little bit thinner. Okay. So it's going to look, hang on a second. Just do that. Sorry, let me see if I can grab hold of this line. There we go. Okay. That is so irritating. Okay, so it would obviously touch the function in one place only. I can't get it to go any closer than that, but there would be a point of tangency over there. All right, so that's what it means if it is a tangent to the function. So can you use A? You can't use A. No, it's going to be a number that's got to be bigger than the point at A. All right. So what can we do? If a line touches another line, so if a straight line touches a curved function in one place only, we say that it is a tangent. What sort of roots would they have? Okay, you're getting warmer, Mr. Bavuma. You're getting warmer. Okay, so in other words, what you're saying over here is let's just do that. Let's take negative x squared plus 2x plus 8. And let me just double check that that is correct. It is. And we're going to make them equal to each other. So equals negative 2x plus k. Okay, good starting point. Now what? Yes, they've got real roots. Can you see that? But more specifically than just real roots, what sort of roots do they have? Exactly, Mr. Bavuma. They would have equal roots. Okay, so the word tangent means equal roots. How do we interpret equal roots using the discriminant? Remember b squared minus 4ac. What does it have to be equal to for? Well done, Mr. Bavuma. Real and equal. Yes, I agree with you. That's it, Ayabak, where they have to be equal to 0. Okay, so for equal roots, b squared minus 4ac has to be equal to 0. So what we want to do here is we want to get everything onto one side. Okay, so add 2x, add 2x. Keep our 8, whoopsie, that's supposed to be 8. Hang on a second, let me just write that out. Not a very nice 8. So we're going to keep our 8 over here and we're going to bring our k over to the other side. So this is now quadratic. No, it's not the only method you can use. You can also use calculus, Blankenberg. Okay. And if you want, I can show you that method as well. Yeah, no problem. Sure. Okay, so yeah, we've been doing a lot of alternative methods tonight, which I think is a really nice thing. Okay, so this is the grade 11 way, right? And probably the most common one that people would use. So now subbing into delta, which is equal to b squared minus 4ac. We know that delta has to be equal to 0 for equal roots. B is 4, so 4 squared minus 4 times a is negative 1, and c is everything else, so 8 minus k. All right, so remember a is the coefficient of the x squared term, b is the coefficient of the x term, and c is everything else in the equation. Now we're going to solve for k. So this gives us 0 equals 16. And now we're going to say minus 4 times minus 1 times 8. which is going to leave us with positive 32. And then we're going to say minus 4 times 1 is 1 times negative k. That's going to leave us with minus 4k, like so. All right, and then I'm going to take my 4k over to the other side. 16 and 32 is going to leave me with 48. And I'm going to divide both sides by 4. And k is going to be equal to 12 in this case. All right, so when the line y equals minus x plus k touches the parabola once, its y-intercept is at 12. Okay, that's what we've calculated. Does that make sense to everyone? See. All right. I'm just thinking about it now. If we used calculus rather than nature of roots, if we took the first derivative, we would end up with negative 2x plus 2, right? That would be the first derivative of our parabola, negative 2x plus 2, correct. We know that the gradient of this particular tangent is equal to negative 2, right? So over here, the gradient of our tangent is negative 2. So if we now make this equal to negative 2, we can solve for the x coordinate at which this happens. So I'm going to take the 2x over to the other side, so that would be positive 2x. Add 2, that would be 4. So this would be where x is equal to 2. Now that I've worked out the 2, what I could do is work out f of 2 to get the corresponding y. So that would be minus 2 squared plus was 2 times 2 plus 8. We're now subbing back into minus x squared plus 2x plus 8. And this would give us a, that would be negative 4 plus 8. All right, so that would be 8. So in other words, what we've got is an x and a y and a gradient. So subbing into y equals mx plus c, okay, or in this case it was y equals minus 2x plus k. Let's sub in our x and our y, so that would be 2 and 8. So 8 would go here, 2 would go there, add 4 to both sides, and k would be equal to 12. So if you wanted to use calculus, that's how you would do it. I don't know which method you prefer. I think doing it the first way is probably a little bit quicker, but yeah, so you'd have to find the first derivative, make it equal to 2, solve for the x and the y at the point of tangency, and then sub that into y equals minus 2x plus k to solve for k. Does that make sense to everyone? Confusingly understandable. Okay, all right, we don't have much time left. I don't know if I'm going to be able to finish everything because we've still got to do the poll as well. Of course you can do this. You are doing it. Okay, you've survived everything, 100% of everything that's happened to you so far. Are we going to do the poll first? Okay, Tisha, I'll go back over that quickly now, just in the last few minutes that we've got. Please answer the poll, guys. Pretty, please. Okay, so Tisha, your question was, where did you get the 2 that you subbed into the first derivative? So in other words, are you talking about this 2 over here? Which 2 are you talking about? Because this is your first derivative, right? So your first derivative was minus 2x plus 2. So the gradient of the tangent is negative 2. So if I want to work out what the x coordinate is at the point of tangency, I'm going to sub the gradient in over here. Okay, because remember the gradient at that point is not equal to 0, it's equal to negative 2. So you go back up and have a look at our diagram over here. So the gradient here at this point of tangency, the gradient here is equal to negative 2. The first derivative is equal to negative 2. It's not equal to 0. Okay, because it's not a horizontal line, it's not touching the parabola at the turning point. Okay, Tisha, so then we've worked out what the x coordinate is at the point of tangency, it's 2. We've worked out what the y coordinate at the point of tangency, it was 8. We know that this line, it's the line y equals minus 2x plus k. So now we can sub in our 2 and our 8. And we can get k in an alternative way. All right, using calculus. All right. Please, can 3 more people answer the poll, guys? Okay, so the next couple of questions, we'll just keep going for another couple of minutes or so. I don't know if I'll be able to do the last question with you, but let's see if we can finish off 5.6. They've asked us to write down the values of x for which g of x equals minus 2x plus j will intersect the graph f at 2 distinct positive x values. So this is one of those sort of more difficult interpretation kinds of questions. I wonder if this line is going to cooperate with me and I'm going to be able to move it. So at the moment, all right, that could be considered the line g of x, okay, because it has a gradient of negative 2x. And what they're saying to us is that this line can move. So in other words, its y-intercept can change, right? That's why they've called it j. But they want us to write down the values of x where the straight line is now cutting the parabola in 2 distinct positive x places. So it's doing that at the moment. So where I've placed it now, there is a positive x root over there, and there's another positive x root over there. So if I continue to move the line down in this direction, once I move it past the y-intercept, I've now got a problem, because what's happening is that it's no longer cutting the parabola in 2 places where x is positive, because over here, x is now negative. Okay, it's still positive over there, but now it's negative over here. So in other words, I cannot go any further to the left than the current y-intercept over there at 0 and 8. Right? If I continue to move it too far this way, when I get back there again, then it doesn't have two positive places where it's cutting the parabola anymore. So it has to be somewhere between where it is at A and when it is a tangent. So when it is over here, it has one root that is 0 and another root that is 4. Strictly speaking, 0 is not considered positive. So it needs to be a little bit bigger than 0, but it's got to be less than where it was 12. Okay, so in other words, we have calculated that the values of x for which it will intersect it at two positive places is going to be when x is a number that has to be bigger than 0. It has to be bigger than 0. Just lost my train of thought. Write down the values of x for which k will intersect the graph with two distinct positive x values. So it has to be where x is greater than 0, k or j has to be smaller than 12. So what was, oh, it was 2, wasn't it? So when it was over here, it was equal to 2. So it will have to be between 0 and 2. Okay, because when x equals 2, it was a tangent. When x equals 0, then we had one root that was equal to 0, the other root was equal to 4. So as long as it is between 0 and 2, then it will still, the straight line will still cut the parabola in two places where the parabola is positive for x. Okay, and I think that's about it that we've got time for.